All right, so we're recording again. Let's just pick up right where it left off. We were proving this like very specific divisibility rule in mod 7, right? Okay, so the reason why this works is when we multiply both sides by 6, this just becomes, or -1, it just becomes negative 3abc, which we can just say, really, if we want to get this specific rule, we should actually multiply by 2 to, or multiply not by 2, but by 5, which is just -2 to get ABC. So we want to make this coefficient here 1 is congruent to 2D, simply multiply by -2 mod 7 over, so times -2, get from here to there. And this essentially implies that. So we just like got a bunch of rules mod 7. We can work backwards and show this as well. But yeah, like that's basically what there is to proving 7. Let me just try to cover the 11 rule concisely again. Just again, like you have a number A, B, C, D, E, F. What this really means is like A times 10 to the 5th plus B times 10 to the 4th plus so on plus 10E plus F. And 10 is congruent to -1 mod 11. So this is A times -1 to the 5th plus B times -1 to the 4th. Minus E plus F. And so this is where the alternating sum comes from. This becomes -1 to certain power oscillates between -1 and 1. And as I said, you just like with the divisibility rule for 9, and unlike the divisibility rule for 7, you can actually easily find out the number mod 11 through the same rule. Just be a bit careful about the sign that you start with if you're doing not only whether or not it's divisible by, but if you want to actually find the remainder of mod 11. So yeah, that's my only like note and warning. With that, here's a problem. Which ones out of 7, 11, and 13 divide 2, 1, 5, 6? Oh yeah, and like please message privately, of course, as always. Oh yeah, tell me like just tell me which one of these numbers are divisible. I don't want any other numbers. Okay, so that's correct. A lot of people said only 7 and 11. That's right. So oftentimes, like, you don't want to, I guess, be too by the book. You want to notice things too. I noticed this is made up like 21 and 56. So if I just divide it by 7, we get 3, and well, sorry, not 14. We get 308 immediately. And 308 is very clearly divisible by 11. We could have gotten this from this number itself, but I mean, 308 is just smaller once having identified 7 anyways. Because this is 3 plus 8 minus 0 is congruent to 11, which is congruent to 0 mod 11. So 7 and 11 divided. You can divide by 13 to check that it's not. I mean, honestly, these numbers are so small in the AMC that if you don't know the divisibility rule, you can probably just test it yourself and see it if it's not a number like 7, 13 that has some kind of like unorthodox divisibility. I would say only remember 9, 11, and the numbers that divide powers of 10, like 2, 4, 6, 8, 5, 10, and others in general. The reason being is because like only those have fixed rules, and because like the other rules are often things you just derive from modular arithmetic anyway, so you'd be better off doing that. Even then, I would still like you to memorize like or understand why The modular arithmetic gives the results, especially for 3, 9, and 11. Those are very important. And what number is A if this is a multiple of 11? And how about if it's a multiple of 7? So you can send me the answer to this in chat once you get it. Okay, so I'll just go over this. Let's take 11 first. 8 minus 9 plus A minus 4 plus 3 must be divisible by 11. So this is essentially A minus 2 is divisible by 11. The only solution being A is equal to 2. If you actually check this, A equals 2 works mod 7, 2. So 8, 9, 2, 4, 3 is actually divisible by 77. Now notice that we want to find like all such A. So although A equals 2 is the only one making it divisible by 11, 8, 9, 2, 4, 3, automatically we can just add 700, make this 8, 9, 9, 4, 3, which is also divisible by 7. So make sure you get all of them. I know it was kind of worded in a way that made you think probably there's only one, but yeah, not the case, sadly. So we have some in-class problems for you to do. What digit could be used to fill in this tens digit blank to make this number 4, 5, 2, blank 8 divisible by both 3 and 8? Kind of similar to one we did before. And what's the largest possible number divisible by 8, 9, 10, and 11 uses all the digits 0 through 9 exactly once? Sorry. Okay, yeah, I'll give you some time to work on these, especially that second one, but do the first one first, I would suggest. All right, so I see a lot of people getting number 1 correct. The answer should be 8. We can see this because 4 plus 5 is congruent to 0, mod 3, 2 plus 8 is congruent to 1. So desired digit has to be congruent to 2, mod 3. And simultaneously, mod 8 has to be 0. So after doing some modular arithmetic work, we see that blank has to be uh equal to a multiple of 4. So 0, 4, 8. Only one of these is 8 is also congruent to 2 mod 3 simultaneously. So 8 would be the answer for this. What's the largest possible number divisible by 8, 9, 10, and 11 and uses all the digits 0 through 9 exactly once? All right, now this one might take slightly more time. And we want largest possible number. Note that since we use all the digits 0 through 9 exactly once, we will be guaranteed that the number has 10 digits. All right, for the sake of time, I'll just go over this problem and solve it on the spot here. The key thing here is this divisibility by 11 actually gives us a lot of good constraints. We already know actually that it's going to be divisible by 9 if this condition is satisfied. Why? Because the sum of all these digits 9 times 10 over 2 is equal to 45, which 9 divides. All right. And we have, let's say, these 5 digits are, this is the leading digit, 1. And each, and like each of the and if we have all these numbers exactly once, we have to have like the sum of all of them, all of these equal to each other, right? Because we have that alternating sum rule. Oh, I see a little problem. Let me just wait a second. So it looks like this actually, or never mind. So we want to split 45 into two numbers who, into like two different sums, which are different mod, which are the same mod 11. So how many ways can we do this? Well, could be 2x plus 11 is 45. In which case we find x is equal to 45 minus 11 over 2, which is 34 over 2. 17 is that. So, or we could have 2x plus 33. And remember, 17 would be the smaller sum of the two. Our other sum would be 28. This case would yield x equal to 6, the other sum being 39. Okay, so now we need to see what we're working with here. We know that this last digit would be, probably we would prefer it to be 0, right? Because we want smaller digit here, and so to make room for bigger digits. All right. So we take each of these cases. Let's take 39 first, since that seems like the extreme case and it will give big numbers. So we can try putting a 9 here. And the rest of these four would sum to 30. So we want to see what numbers would satisfy the divisible by 8 condition, because really we've already satisfied most of everything else. All we need is that, like, this makes something that's divisible by 4. And we want all numbers different. So if we think about 4 numbers having to sum to 30, the possibilities really are kind of limited, because 30 over 4, let's see, that's around, that's really around, let's see, 15 half, which is 7 to 8 on average. So this actually may not be achievable in this case, which means we'll have to keep looking for other cases. Well, these numbers would have to sum up to merely 6, which you cannot do with just that many numbers. So yeah, that would not work. I think the next thing we should do is try 5 here. Although once again, we see the problem that there's no way this is going to get to 30, so we're gonna have to scrap this idea, at least of making the digit here 9. If we want something big enough, we're gonna have to make it as small as probably 8, or not even, or 8 is really, 39 is not very achievable, because that means on average the digits will all have to be 8 or 7, which, like, there's not enough digits for that. You have to use it at least once, even to fill up just these 5 blanks. So it looks like we'll have to go with 28 here. So now if we try 9 here, 0 here for this 28, numbers, and remember, we want, like, to take the dent out of the bigger sum. So then we'd have the rest of these 4s on the 19, right? Well, let's see about that. This has to be even, first of all, otherwise it wouldn't even divide 4. We want it to be small as well. And then we have three numbers summing to 17. We can pick 7, 6, and 4. Or actually, yeah, 7, 6, and 4 would be good for this. The reason being is because we kind of want to leave this space here open for 8. And we check that this sum is 16 plus 10 plus 2 is indeed 28. And the sum here would be 17. And the numbers left that we haven't used are 1, 3, 5. Really any of these work. So if we had, because like 320, 520, 120, they differ by 200, all of them there's by 8. So it would really be 1, 3, and 5 in like descending order. So it's really almost, it's just slightly out of order. 9, 8, 7, 5, 6, 3, 4, 1, 2, 0. Notice that if we want to like swap the 6 and the 5 kind of, that would kind of throw it off balance. But for mod 11. And if we wanted to change this to 5 instead of that, this would be difficult because this would make this all, you'd have to like change these two and you would get something that's bigger. So yeah, this is this should be the largest answer. Although I admit these problems are not super easy and you might need to take some very careful checking to get it right. So yeah, always remember, first try to maximize the number of digits, and then you try to, if that's fixed, then you try to maximize what's in each digit position. All right, so yeah, it's all right if you weren't able to solve this, since like that did take a while and it's not very easy. And yeah, there's a lot of people in different time zones. But anyways, class is over now. Homework will be up shortly, and we will start assigning practice AMC 8s as well, since we are nearing the actual exam date. So yeah, so we should like start preparing for that as well. Try to like finish the homework. I see good amount of you are still turning it in. I really try to do it like maybe over the weekend or sometime when you're more free, and try to squeeze in a practice AMC 8 as well if we assign that. So yeah, we'll have the homework up shortly, and with that, yeah, class is dismissed.